Thanks, everyone. Thanks for your patience. So, as I was introduced, I'm Victoria Tozer Pennington, and I'm editor of Airline Economics magazine. And we've been writing about ESG carbon emissions with aviation for at least the last 5 or 6 years, but it's really exploded in the last few. If I could just ask my panelists to shortly introduce themselves and tell us a little bit about your role.
Good afternoon, everyone. I'm Holly Boyd-Boland. I lead the corporate development and sustainability team at Virgin Atlantic. For those of you who don't know much about Virgin Atlantic, we're a long-haul only airline founded by Sir Richard Branson back in 1984, now jointly owned by Virgin Group and Delta Airlines, and really focused on customer innovation, journey experience with the transatlantic, the core of our network.
Great. My name is Freya Burton. I'm the Chief Sustainability Officer at LanzaTech. LanzaTech is a company that's developed a biological platform to take waste carbon in the form of pollution and convert it into the feedstocks for things like sustainable aviation fuel.
Hello everybody, James McMicking. I'm Chief Strategy Officer at a company called Zero Avia. We're developing zero emission engines for aircraft based on hydrogen electric fuel cells. Good to be here.
Hi, I'm Paul Hutton. I'm the Chief Exec of Cranfield Aerospace Solutions. We're a UK aerospace company that's been around for about 30 years, and we hold regulator approvals to do complex modifications to existing aeroplanes. So our plan is to deliver the world's first zero emissions hydrogen fuel cell powered aircraft in 2026. That'll be a converted Britten-Norman Islander. Again, Britten-Norman is a UK aircraft manufacturer, and we announced recently that we intend to merge with that company. So what will result there is a unique business that will combine both world leading technology on zero emissions hydrogen fuel cells for aircraft and be an aircraft OEM.
Hello, I'm John Holland-Kay. I'm the Chief Executive of Heathrow Airport. We're one of the biggest and best connected airports in the world. And for the last 5 or 6 years, we have been working with airlines such as Virgin and companies like Zero Avia and LanzaTech to try to have a plan to get global aviation to net zero emissions by 2050. And one of the big things we were working on up until October last year was to get a global agreement by governments to net zero by 2050, which we achieved at ICAO in Montreal. So now all countries are working on the path to net zero aviation.
Thanks, John. So, as you rightly said, aviation is committed to reducing its carbon emissions by 2050. Indeed, some airlines have said they could reduce by 2040. There really is enthusiasm in this space, and there is a lot of work being done. Even in the era of flight shaming, companies really are committed to reducing their emissions. Leasing companies too, which lease the aircraft to the airlines, have also committed to net zero. And they've just recently had a charter set out disclosing how they disclose their emissions and how they can encourage airlines, their customers, to cut their emissions as well. We've already heard during this conference from banks and financiers. They're doing a lot of work to help ensure airlines do cut their emissions as well, with sustainability-linked loans becoming really exploded in the last year or two, and airlines have been set very ambitious targets where the pricing mechanism adjusts up or down whether or not they meet those targets, which is really a big incentive for everyone. And I just wanted to say that it really is, I mean, the aviation industry is not a pariah, but it's very visual, and you can see the flight shaming, and we have been kind of pilloried in the press for being a carbon emitting industry, but there are also a huge amount of skill and talent in the industry that has advanced the aero engine since its first commercialized in 1950 to 80% more fuel efficient today. And that we are really on the cusp of an industrial revolution in the development of different alternative fuels, better powered engines that really are going to decarbonize flight, which we're going to talk about today. So just first, I'd like to maybe take a look at where all the companies represented here are on that decarbonisation journey. So, Holly, I'd come to you first as the airline. Can you just give a bit of perspective about where you've come from and where you're going?
Yeah, and I think I'll perhaps start just by echoing the point that John made. I think as an industry, collectively, extending across airlines and the full energy value chain, there is a commitment to net zero 2050. We see that in the UK, we see it in UK government, we see it at IATA, the International Collection of Airlines, we see it at ICAO. So I think in terms of setting and being committed to an ambition, there is really broad alignment across stakeholders. I think when I put that into context for Virgin Atlantic, we recognise there are multiple levers we have to decarbonise, and that ranges from operational efficiencies, fleet renewal, use of sustainable aviation fuel, and new technologies. But I think from our perspective as a long-haul only operator, in the here and now, the two levers that we are most focused on is fleet renewal and fleet efficiency, and the use of sustainable aviation fuel. And if I start perhaps with fleet, I think it's a position where Virgin Atlantic has taken an industry-leading position. 75% of our fleet is already next generation, which means it operates on twin aircraft. They are the most fuel efficient, and by virtue of that, they are the most carbon efficient. That has allowed us to reduce absolute emissions by 35% over the last decade, and it means that when we fly today, we have I'll call it a structural advantage, but kind of the carbon profile of flying Virgin Atlantic is often outperforming peer set. However, I think despite the fact we see consistent innovation, development, improvement in operational efficiency of traditional fleet, it will only take us so far, and those returns will kind of be diminishing over time. So I think that then brings us onto the focus that we now have on sustainable aviation fuel. And when we talk about SAF, and Freya will do a better job than me, but essentially it is a fossil replacement drop-in fuel made from renewable feedstocks. That means that the challenge of operationalizing it today is limited. It operates in traditional engines, airframes, infrastructure, and allows almost a like-for-like replacement of SAF. So I think we as Virgin Atlantic have been really focused on what more can we do in this space. We have partnered early with companies such as LanzaTech, one of our longest standing partnerships, to look at really production and offtakes. We've been doing a number of things in this kind of test and learn space to demonstrate that operationally we can deploy SAF as a like-for-like replacement for fossil. And that has included a number of test flights, and we'll see later this year Virgin Atlantic is leading an industry consortium to operate kind of the first 100% SAF flight across the transatlantic. So whilst I think that is all helpful and supports the case for adoption, by the time we probably hit 2030 in terms of feasibility, I think we recognise there remains a massive barrier to scale, investment and production at commercial scale. So when we think about how do we make a difference in the transition in the timeframe we have to 2050, for us, our real focus is SAF.
Absolutely. So we'll definitely come to that later. John, I want to come to you, as you know, the biggest airport in the country. Kind of, you've already said you're committed to net zero, but what else have you done, and how has that journey been for you?
Well, I can remember in the early days when we were getting support for Heathrow expansion, one of the questions I'd often get asked is, what are you doing about carbon? And the industry position at that time was that carbon emissions should be capped and kept level at the volume they were in, I think, 2019. And when I started to be questioned by other people about that, and I started to question myself, and went up to the Cambridge Institute for Sustainable Aviation for sustainable leadership, and I had my eyes opened about the challenges that we're facing. And I think that anyone who's here in the early sessions will have heard just how quickly this is happening. And we decided that we either had to change our jobs or we had to change the sector. And because we didn't want to be the new tobacco. And we wanted to be able to look our children in the eyes and feel we've done everything we can. And that's why you will hear airports and airlines and others campaigning to get to net zero aviation, because aviation is a fantastic thing. It supports all of our lifestyles, all of our, many of our jobs, much of the global economy, but it cannot sustain as it currently is in a world without carbon. We've got to play our part by 2050. And we'll hear there are three main things that need to happen in any roadmap to get there. One is about the change in technology, which Holly touched on. Some of it is about change in airspace, which can reduce emissions by up to about 8% by flying in straighter lines. But the big one is by changing the power that is used, a combination of SAFs in the short term, electric and hydrogen that we'll hear from. And those are now moving far faster than I thought they would when we set off down this path to net zero aviation 3 or 4 years ago. And the question is, how quickly now can we scale up? And if we want to get to net zero by 2050, we will have hydrogen and electric in the mix, and we need to promote those and get them scaled up as fast as we can. But SAF is the only solution for long-haul flying by 2050. Beyond 2050, long-haul hydrogen planes will come into play, but we're probably talking about the second half of the century rather than the first half at scale, by which I mean replacing all the planes that are currently in operation. So we have to focus on getting SAF scaled up. And what we've seen over the last 12 months or so is other countries starting to move ahead with the policies they need. The US has moved quickly. SAF is included in the Inflation Reduction Act. That's a $370 billion investment. The Europeans are moving to respond to that. The UK has not yet responded. But what we're seeing is that decarbonisation is happening at a faster pace than we thought it was going to be, but not quickly enough for where we need to get to. And in the UK, we need to accelerate that transition with the government policy support to help scale up production. And the kind of things we are doing as a private business to help support that while we're waiting for government policy is to put in place an incentive for airlines to use sustainable aviation fuels. This year, that's worth just under £40 million. And we'll see more sustainable aviation fuel used at Heathrow than any other airport in the world. And that is sending a real demand signal to producers that we are going to be on track to get to 10% SAF use by 2030. So those kind of things help. But what we really need is government policy support to scale up a UK production. So we're not reliant on imports from the Netherlands and Scandinavia and the US to meet the UK's environmental targets.
Right, absolutely. We're going to talk really in depth about SAF just shortly, Freya. But before that, I wanted to come to the innovators, really. James, I mean, you're developing an aircraft that can fly on hydrogen. Do you want to tell everyone a bit more about that and kind of the challenges, I guess, involved in using those fuels?
Yeah, absolutely. So Zero Avia has been running for about 5.5 years now, and in that time we've built 3 prototype engines, fitted those to aircraft, and operated them, demonstrating the viability of hydrogen electric powertrain. And today we're flying in the UK a 20-seater aircraft, a Dornier 228, with one of these engines on board, powering the aircraft. So the technology is there to begin this journey and this transition into hydrogen. And we're not just solving the engine challenge, we're also addressing the infrastructure challenge. So down at Kemble, we have our own production facility. We can transport the hydrogen to the aircraft, refuel it, and that refueling system can actually drive to wherever we need it in the network. So we're solving the infrastructure problem as we go. And we won't just stop with a 20-seater aircraft. We announced just 2 weeks ago we started work on an 80-seater turboprop. So this is a de Havilland Dash 8 aircraft in partnership with Alaska, and have demonstrated a 2-megawatt engine operating on the ground for that aircraft over in the US. But the company is 2/3 in the UK. We develop our in-house fuel cell technology here, and this technology will scale to larger aircraft in time. And I think listening to the presentation at the beginning of the day, it's clear that we need to move faster and faster with innovations like this. And we are reaching the point now where we can put more trust and more investment into these types of businesses to accelerate that process, because we can go faster and we want to go faster. So it's a very exciting period.
Indeed. Paul, can you talk more about the hydrogen engine? Because we've just spoken about it's a longer term goal for at least longer haul aircraft. What's your opinion on that?
Yeah, so I think, as you say, there can be a perception that these new technologies, the zero emissions hydrogen propulsion systems, aren't going to come in for many, many years, and there's talk of 2035 plus. In actual fact, we can get these solutions in much quicker than that. So our first aeroplane will be flying in 2026. We'll then upgrade that to a liquid hydrogen-fueled aircraft in 2028 that will give it greater range. We'll go from a 9-seat up to a 19-seat. And then by 2032, we can have a 50-seat brand new aircraft design flying. So we can start tackling this problem much earlier than perhaps the market perceives. But also, what's really, really important is what will be delivered into the large single-aisle and twin-aisle aeroplanes in 2035 plus will be developed from what we do today on the smaller aeroplanes. We've moved beyond incremental improvements in aerospace engineering, which is where we've been for the last 4 or 5 decades. This is revolutionary. We need to go back to the small aeroplanes, prove these immature technologies in those small aeroplanes, and then incrementally build that up. That's the challenge we're taking on, and we can do that very rapidly. All those skills exist. All that innovation capability is here today. All we need is enough funding delivered as quickly as possible to make that happen. And that journey can get there much more quickly than I think is currently perceived today.
I think that's right. I think the 15-20% efficiency changes over maybe 10, 15 years. We're going to jump forward in that really quickly with the right investment and policy behind me. I think that's.
I think so. And also what we're finding as well is that you quickly realize that hydrogen-powered aeroplanes can be more cost-effective to operate than conventional aviation-fueled aircraft. So hydrogen is a very energy-dense medium, so you need significantly less fuel. So that starts to make parts of the market much more commercially viable. For the last 4 or 5 decades, sub-regional, regional aircraft operation has had very little investment because conventional wisdom said you needed ever larger aeroplanes with ever more passengers on board, traveling ever longer legs to make ends meet, to make the commercial operation work. As the costs go down, that starts to make sub-regional aircraft and regional aircraft much more interesting, much more viable. So we think these smaller aircraft will take a greater proportion of the market, and that accelerates their impact on CO2 reduction significantly. This is the place where we have to start. Get these aircraft, the smaller aircraft flying, and we'll get to the aim that we all want to get to of reduced CO2 much more quickly.
Yeah.
A quick additional point I'd like to make. I agree with Paul on the economics. You can definitely see a future where it's lower cost. But the additional benefit of this type of technology is you get a deeper cut in the climate impact than you can achieve through sustainable aviation fuels. So the fuel itself can obviously be generated using purely clean electricity through electrolysis. But then when you use it, you don't produce any or far fewer of the non-CO2 effects in aviation. So that is a problem the sector has to address on top of carbon, and it may be as much as twice the impact due to those non-CO2 effects. The climate science is still very much at its nascent stage, but we have to start thinking about that, and hydrogen gives you that deeper penetration in terms of climate impact.
Okay, absolutely. Freya, I want to bring you on now because Holly's already said we are using sustainable aviation fuel now, and the percentage of the blend is going up and up. You're going to do 100% fly with your partners. Can you tell us more about the switch to alternative fuels, the challenges that we're going to face, and kind of the progress that your company has made, and what you're doing to push that forward?
Absolutely. I think the first thing I should say is, and echoing what John and Holly said, you need a whole basket of solutions for your decarbonisation targets. And the same goes for SAF. So you can't just pin your hopes on one type of feedstock, one type of technology. We're going to need everything. And we're going to need SAF, and we're going to need hydrogen, and we're going to need electric. We're going to need all shots on target to meet our goals. Because choosing the perfect solution, it thereby is a big mistake. So we need to think about how we can have a holistic view of contributing to our decarbonisation goals. SAF plays one part, and as you rightly said, there's been a lot of progress in the industry as a whole. LanzaTech is really just one player in this SAF industry, where we're looking at taking waste feedstocks in the form of pollution and using that to make the inputs to make sustainable aviation fuel. The reason why using waste is so important is because if we look at where we are today in terms of SAF, and we look at where we need to get to, even for our, could be a little bit more ambitious targets for 2030, it's kind of less than 1% of where we need to be. And that is overwhelming if you think about how much we need to produce. So the only way we're going to get there is if we open up all the sustainable and possible feedstocks. And they have to be low cost, they have to be available, they have to be sustainable. We can't pin our hopes on one type of feedstock. We're never going to meet the targets. And so there's been a lot of progress in terms of opening up what kinds of feedstocks are, one, certified for use, because I don't know about you, but I don't want to get on a plane with a fuel that hasn't had all the certifications. But also fuels that meet sustainability credentials, very important. We can't just let anything participate. But there is the issue, and that's one of our challenges today. There's a lot of technical challenges that have been overcome. But today, our biggest roadblocks, and John mentioned this as well, it's the speed at which policy is creating a market for SAF. And the intent is there. There's a lot of real leadership, especially in the UK, being shown for the SAF market and creating opportunities here. But it's taking too long. And that today is our biggest challenge. It's not technical, it's a policy one, which then leads to money. Because if you're an investor or if you have a project that's going to need a final investment decision to move forward and put steel in the ground to start making those volumes of SAF, you want to know that you can sell it into a market. And if that policy framework's not there, you won't get the investment. So that is a real challenge today.
Yep, so the amount of SAF is too low. The policy isn't there. The certification perhaps.
I said I wasn't going to be a doom monger on this. I was trying to be optimistic. There's a lot of potential there. There are a lot of opportunities there, but it's a speed element. And until we unlock that policy roadblock, we can't get all the money. The money is there. The desire to invest, the desire to produce, or the ability to produce is there, but we're just waiting, sort of waiting.
Yeah, John.
Can I just come in on that? And when you talk to the big financial institutions, they are desperate for sustainable infrastructure that they can invest in. And the SAF is one of the most attractive that they can see. It's a well-established technology. It's been around for 80 years. What they're looking for is some confidence to help them to scale up. What we have in the UK so far is a mandate that sends a demand signal of 10% by 2030. That's a really big demand signal. What it doesn't do, though, is drive investment here in the UK, because we can buy that from subsidized production coming out of Europe or out of the United States. If we want to create a UK-based SAF industry, which is one of the things that LanzaTech is keen to do, we need to have the right kind of financial framework here to support it. And that means something like a contract for difference or another financial stability mechanism, which allows LanzaTech to go to a bank and say, I've got a guaranteed revenue stream, and on the basis of that, you can start to invest in my getting me to scale up. And if we don't have those kinds of measures, the UK, having led on a lot of the campaigning to get the world to net zero, will watch other countries take advantage of the switch to net zero, and we will be left behind. And I think that would be a real crisis or tragedy for the UK. When we could lead, we could end up being dependent on somebody else's energy supply.
I think that's exactly right. I think we've seen a lot of money being poured into California. There's a lot of companies out there that are producing alternative fuels and getting the backing to do it. But SAF is really, really expensive, isn't it? When we know we've understand the supply difficulties. I mean, Holly, you've had to go out and have contracts with producers to secure even a small amount of SAF.
Yes.
And it's very expensive. So just share your experience with that situation.
Yeah, I think when we've looked at the kind of market, the opportunity, I think I would mirror kind of what's been said across all technologies, across all pathways. Right, when it comes to SAF, it's about a portfolio approach. Part of that is geographical, part of that is technology, part of that is producer. But I think when we face into kind of the price premium that we see today, it's 2 to 3 times the cost of Jet A. I think it's well established that aviation is sensitive to fuel cost, and that creates not a lack of demand or a willingness to procure, but it creates a challenge and a confidence dilemma on both the demand and the supply side as to what that tipping point is. Now, when we've looked at the market, and I think John alluded to it, Freya alluded to it, we're starting to see policy as the real catalyst for investment. So as a UK-based airline with 50% of our fuel uptake in the UK, it would be the place we would want to start. When we look across the market, we see that actually the incentives that are available in the US, kind of a commitment from the government to build a revenue stream for producers that helps bridge that cost of production gap. As a result of that, we see 60% of announced capacity for 2030 in the US. We see a price premium that is materially lower than what we're able to kind of procure in the UK, assuming that plants that Freya is looking at and other players are looking at can get to financial investment decision and actually can enter production. So I think that then comes back to John's point, right? Where are airlines looking to procure? Bluntly, where there is going to be greater certainty on production and price, that's currently not the UK. And from a governmental perspective, I think there needs to be more conversation or kind of more follow through on the ambition that we don't want to be an import reliant aviation sector. I think for us strategically, that would be a disaster. I think for us economically, socially, it would also be a pretty bad place to be. So I think from that perspective, we're still seeing, and I think this will be critical to the next 10 years, and I would argue the next 10 years also critical to achieving 2050, that policy has to be the catalyst, and the catalyst isn't kind of taking place today in the UK.
Yeah, I mean, scaling up, I mean, that's one problem. We have to scale up. We have to do it internationally, but very much your airline's based in the UK. You need it here. You need that infrastructure. I just wanted to look at infrastructure challenges. I mean, John, if I could ask you, if we're going to have electric power, jet fuel, SAF, potentially hydrogen, what does that mean from an infrastructure point of view? You know, you're fueling all of these different aircraft. So it's a headache, right?
It's a much more complex energy supply chain than we've been used to. I mean, one of the attractions of SAF is it can be dropped into existing planes, and it can come in the fuel pipelines from all over the UK into Heathrow. So it's relatively simple from an infrastructure point of view. But we're starting to plan for hydrogen and electricity. They will be part of the mix increasingly, and I completely agree that the kind of the pace at which hydrogen is moving is far faster, I think, than anyone thought, and it will start as we've heard with smaller planes. We would expect that the mid to late 2030s, it will start to be a more substantial part of our mix at Heathrow, and by the 2040s, we'll start to see it stepping up a bit. There are logistical challenges with hydrogen. All of these technologies take a vast amount of electricity, so you've got to have the electricity supply network to come in to support it. You also, in the early stages, you can tanker in the hydrogen that you need. But with the scale of Heathrow, and we use half of all the aviation fuel in the UK just at Heathrow, so it gives you a sense of the volume that we have, we will very soon get to a point where we need to have liquefaction on site and a hydrant system that we need to retrofit into the airport. And that needs to be under pressure and super chilled to be able to keep the hydrogen liquid. None of that is impossible to do. It just needs to be planned in. So we're starting to do the planning for that. We don't think we'll need to make substantial investments in that until the early 2030s, when we'll start to see more certainty about the demand side coming through and the technology. But we need to start planning that today, which is what we are doing. So it's actually a very exciting time. And somebody was telling me that we will need to become energy experts just as much as we are aviation experts.
Yeah, I think that's right. I mean, Paul, James, do you want to come in on the hydrogen infrastructure? I think you've already mentioned, James, that you're building that into how you're developing the aircraft. But I mean, same with you, Paul. Is that something you're looking at as you're developing the engine?
Yeah, very much so. So just like the technology, the hydrogen fuel cell technology will come into the small aircraft first, I think also we can solve some of the problems that the larger airports will need to deal with, such as Heathrow, by introducing this technology into the small regional airports. So it's a much less complicated environment to work within, but we need to solve the problems of all the, and it's slightly boring, but standards and processes that go with safely storing hydrogen in these locations, moving hydrogen across the field, plugging that hydrogen into an aircraft. What do you need to do to test that fuel to make sure that if there's a subsequent problem, you've got a sample of the fuel. All those things that we take for granted now with conventional aviation fuel, we need to build those processes and standards for hydrogen. Fortunately, many of these small airfields are also in places where they generate huge amounts of green electricity. So many of the regional aircraft are operated on the coasts and between islands. There are many occasions during the day when they're generating more green electricity than they can actually make use of. So rather than feed that into the grid,
I think you've gone off there.
and feed that into the grid, electrolyzer technology effectively creates an energy storage medium for those localities. So you're creating a hydrogen hub. Hydrogen is becoming the battery to store the green electricity when it's not needed on the grid. That, at the same time, is creating the fuel for aerospace use, for ferries and boats, and for heavy ground vehicles, for which batteries are just not the solution. So we don't see any lack of demand, or the demand stimulus will cause the need for the creation. I think we need to make that step, first of all, in the... is that any better? In the smaller airports, where we can solve the problems, create the standards, write the processes, get them approved, so that then by the time we get to Heathrow, and it's a much more complex problem, we're in a much better position to transition, in the same way that by solving the technical problems in the smaller aircraft, it's a much smaller step to get into the single aisle and the twin aisle. large aircraft.
Yeah, I think that's exactly right. So
I'll jump in. We don't need to solve all of the problems
all at once.
just all at once, right? Clearly, Heathrow is exceptional in scale. But as Paul says, we can think about how we scale up through these smaller aircraft. And for us, we can get hydrogen where it's produced, wherever that is produced, and transport it to the airfield and provide fuel for several aircraft and then go and collect more fuel off-site. So the airport doesn't need to necessarily worry about storing or producing hydrogen to begin with, and we can support those operations. Now, a lot of airports are seeing the potential of this transformation, though, and the opportunity to decarbonize the whole of the airport environment and to interact with the rest of the power market differently. A good example is Edmonton International Airport in Canada is putting in 120 megawatt solar fields. We're working with them to think about how to bring hydrogen aviation ecosystem to the airport, but they're thinking about this bigger opportunity to become part of the power market there, to use that electricity to optimize how they can decarbonize the entire airfield and all of the ground transport that's associated with it.
Yeah.
Now, they've got the real estate to do that, which is more challenging at Heathrow. But it depends where you are really. But the scaling up process is a lot easier to solve than we think, and we thought through those steps. Eventually, we will have much bigger on-site liquefaction or production solutions around airfields. But right now, all we need is a mobile refueler, and we can go support aircraft operations.
That might become a concern if there's a whole transition towards hydrogen for freight, ground freight, and trains or whatever. Is there going to be competition for kind of fuel source? I mean, it's part of the scaling up challenge, right? And the whole infrastructure around the UK. So do we need to be working with other transportation partners and other utilities? Really?
I think generally working more closely with other major consumers of fossil fuels and energy is really important here. I mean, SAF, we're not the only sector that wants sustainable fuels, and we're all going to be going after the same fundamental source of that. Right the way back to the energy infrastructures used to generate the electricity to make that fuel. So we do need to be adding these things up and making sure we're optimizing, how it's consumed for the right purposes.
So, did you want
Yeah, and I think this is where government policy comes in. We need a master plan for how we decarbonise the economy.
Yeah.
And there are some important principles here that if we look at SAF, there is enough waste supply in the world to meet all the future needs of aviation, just to create sustainable aviation fuel, but not if we waste it on
Power.
uses where you can use electricity or some other source. So cars and long-haul trucking are going to be a waste of scarce biofuel, so that's an important government policy decision to make.
Right.
And if you were to convert all of the biofuel that currently goes into vehicles into aviation, that would be about 15% of all the capacity that's required for aviation.
That's huge.
We already produce a huge amount of biofuel,
Yeah.
but we send it to the wrong place from an energy transition point of view. Now that might be okay today, but in 5 years or 10 years' time, we will need to be diverting it to the place where it has the highest utility, where there are the fewest alternatives, which will be long-haul flying.
I think that's right. I mean, Freya, do you want to comment?
No, it's 100% that. I mean, today we have this ridiculous situation where we're taking these viable feedstocks for SAF and we're burning them for power when we know that we can get power from renewable sources,
Right.
whereas the aviation sector is a very hard one to decarbonize. So it really seems a little bit kind of crazy to not be diverting those feedstocks or having things in place to divert those feedstocks to the sectors that need them.
So we need policy, we need regulation. I mean, the aviation industry is doing quite a lot to avoid being told what to do in terms of regulation. Yeah, but I think in this instance, we really do need that to make sure that we're getting what we need to get where we need to go to. So there is an argument, isn't it, that all of this is still too slow. I think we're moving quite quickly, but I mean, are there other options? I mean, some airlines have invested in carbon capture, for example, venture capitalists. I mean, Freya, have you got anything to say about that?
Yeah, I mean, I sound like a broken record, but we need all shots on target. We need to look at carbon capture and utilization. We need to look at different SAF pathways, and we need to try them all. The problem is today, a lot of our approaches, either be UN reports or government frameworks, are all kind of dependent on the perfect solution. And you see that in a lot of SAF technologies or pathways have incredibly challenging either sustainability criteria, greenhouse gas reduction thresholds. Don't get me wrong, we need them, but also limits on how they source their hydrogen. So hydrogen for especially carbon capture and utilization technologies taking CO2, they need an energy source, they need clean hydrogen. And now there are, in Europe especially, there are really complicated temporal rules around how they're sourcing renewable power to get the energy they need. And I was joking with someone earlier that, this is a kind of, it reminds me of a quote from Ginger Rogers, Dancing with Fred Astaire. She had to do everything in high heels and backwards. And I feel like SAF producers are really doing that. They're being given really strict criteria. The bar is being raised at every moment. And the ones who are succeeding to continue to fuel aircraft are those using virgin fossil inputs. And so back to your question on price, is it really fair to have an apples to apples comparison? I know it's the only one we have today. And looking at what was said this week from Boeing, that, SAF will never be at parity with fossil jet. Well, no, because we're not taking the real costs of jet into account, and we likely never will. But that's an industry that's had, 100 years to get down the cost curve, to have baked-in incentives and so on. But why is it so much harder for the SAF industry to realize any of those opportunities? And that's what's another challenge that we face.
Well, there may well be a carbon premium put on jet fuel eventually. When you don't know, policy might go that way, but.
It's a good point. We just don't know what the carbon price is going to be in the future. We don't know what the fossil price. The price volatility is always going to be there. But at the moment, it's always compared to, this is what you're the fossil price right now.
Yeah.
And that's effectively what we're doing with our incentive at Heathrow. We're bringing down the cost for people who are using SAF like Virgin, and we're putting up the price for people who are using fossil fuels.
Okay.
And there is a price to be paid for carbon. And it will cost more to fly, particularly in the early years. And we have to face into that. Now, we're not going to go to 100% SAF overnight. It'll take a while. So as we go up the production volume level and we come down the cost curve, then the proportion of SAF that's in your plane will start increasing. But it'll start with a very small level that you'll barely notice. And as the costs come down, it'll become an increasing proportion. But it might still be more expensive than jet fuel today. But if that's the price for being able to fly, it's a price worth paying.
Yeah.
And I think in the early stages, we need to make sure that those who have the money, particularly the global north and big businesses, need to be paying that premium. And that's what they're doing.
Yeah.
A lot of Holly's customers are asking for sustainable aviation fuels because they now have to report their Scope 3 emissions.
Exactly.
And they can afford to pay the premium. And that's the right thing to do. They can help fund the early expensive phase of the transition, get the cost down for everyone else, so that the global south, when they come to switch to SAF, find a much lower input cost. And one of the things we're encouraging companies to do is to commit to buying 30% of their fuel with SAF with their airlines such as Virgin by 2030 to help to commit to funding the transition and giving the kind of pricing signal that LanzaJet need to see that they've got the revenues in the future to invest in their plants.
Yeah, I have a million questions still to go, but I've only got a few minutes, and I really want to talk about the consumer and kind of, are they going to pay more? Will they going to pay that SAF premium? Are they going to pay a carbon premium? Holly, what's your experience so far? Do they buy offsets from you, for example?
So I think it's probably a bit of a mixed bag, right? And coming back to the question or the point that Freya raised, right? Do we properly externalize and recognize the cost of carbon today? Probably not. Do we on an economy-wide basis? Probably not. But are we starting to see an increased cost associated with transition? Yes. Will that continue? Yes. Should it continue? Yes. Will the transition be free? Of course it won't be free. And then you get down to kind of the question of, well, who pays, right? Who funds the cost of transition? And if we take offsets as an example, so kind of out-of-sector purchases, they're not in-sector reductions, which I think should be everyone's bias, but they will play a role for aviation transition. There's kind of three ways we see offsets coming to the fore. There are compliance-type offsets. We see kind of international aviation regulation schemes such as CORSIA. We see voluntary kind of offset engagement from companies as they try to meet their own voluntary targets. And we start to see kind of this consumer angle of offsets. And I'll kind of link that piece perhaps to a broader point on consumer willingness to pay. And within that bucket, I will include, offsets, SAF, externalizing cost of carbon through emission trading kind of schemes. And so what do we see from kind of a consumer perspective? Well, we see, I think, undoubtedly increasing awareness. And we see kind of a stated preference from consumers that both they recognize the challenge of decarbonisation, they recognize there's an associated cost, and they're willing to lean into covering some of that cost. I think what we then go on to see when you actually get to kind of a level of revealed preferences, right? Do people actually put their money where their mouth is? We see less positive trends. And I think that probably cuts across all customer segments. And I'll kind of give you 3 examples. Corporate customers, I mean, John leads some great initiatives on that, and there are very sophisticated, very carbon kind of active corporate companies that are leaning into this space to share the premium with airlines and with players across the energy value chain. And we see that kind of through partnering with airlines, through corporate SAF schemes, and we see it through kind of standalone kind of buyer alliances that are looking to adopt SAF, reduce their own emissions, and kind of help support the demand signals that there are out there in the market. But then if you come on to kind of the kind of leisure customer kind of segment of the market, we see a lot of people, again, kind of stated preference, 80%-ish, will say, I'm willing to offset my flight, less than 1% do. Right? And then when you put it into kind of today's choices for both corporate customers and leisure customers, we see increased transparency. There's some methodological improvements to come, right? That when you look, search, book, consider your flights, you get a steer for kind of the carbon performance of the airline you pick. At no price premium, we don't see that as a primary driver of choice. In fact, carbon doesn't make it into the top 5 drivers of purchase today. So yes, there's increasing awareness, ambition. We still have quite a material say-do gap.
Right. So we've only got 1 minute left. I just wanted to try and end on a really positive note. I mean, the facts are people want to fly post-pandemic. The trajectory of growth has just gone through the roof. We're going to be back to 2019 levels by next year, if not later this year. So, I mean, what's your thoughts, just really quickly, on the future of flight? Do you see short-haul flying being banned? Do you see everyone willing to pay more, or fewer people flying? I'll start with you, John, and I'll come down the line this way.
No, I think, I mean, decarbonising aviation is happening. And I don't think we got to that Tesla moment yet where you go from saying it's never going to happen to, well, of course it's happening. But we're not far from that. I think in the next 3 or so years, we will get to that point as we start to see the production scaling up and the use scaling up, and things like the Virgin flight from Heathrow to JFK on 100% SAF and the 50-seater hydrogen planes. Those are making it a reality, and it's just a question of then scaling it up. And I think we're very close to that. And I think that energy transition will be funded by big companies who need to fly and are able to pay for it. But I'm really optimistic about the future for aviation. It's a fantastic thing, and we can keep doing it.
Yeah. Paul.
I'd echo that. I'm very optimistic about where we can get to. The technologies that we can deliver, they're all in the roadmap. We can deliver them without any problems at all, I think, over the time frame that we're talking about here. What will help, what will make the difference, is a combination of policies from the government to support the adoption of those technologies. Because, say, for example, if the UK government pressed to have all domestic flights of less than 60 minutes in the UK, zero emissions by 2028, that seems quite challenging, but the technology is there to do it. That creates a buying signal for the sub-regional airlines to have to look for aircraft product to buy. That then creates a signal to the equity markets to say these aircraft are really going to be bought. So it starts to stimulate the flow of funds into the R&D. So those sort of policy initiatives can really make a difference. And then secondly, into the funders in the equity markets. We have the capability here. We have the companies with the capabilities and the experience to deliver zero emissions hydrogen fuel cell powered aeroplanes in the UK. We just need the funding. If we can generate that funding in the right quantity, we can accelerate this.
Thanks. James?
Yeah, very quickly. We need to accelerate the technologies. The funding is really important to do that. The UK has a little bit of a track record of not going fast enough at the right moment. I think we've now reached the right moment in this industry where it's hit the accelerator on these technologies. If you can shoot for something like domestic aviation zero emission within this decade or early next decade, that would be a great goal to stimulate it. I mean, we could take less than 0.5% of UK's offshore wind power and turn all of the domestic aviation net zero emission using that amount of power. So it's like very, very credible. The technology is credible to power those aircraft. So for me, it's optimistic. I'm excited about the future, but we do need to move fast.
Read up. Yep.
Yeah.
Freya?
I am going to end optimistically, even though I shower doom on
I
everybody.
think you've got the most challenging.
But it's it has to happen, and it will happen. And we've got companies. We have our sister company LanzaJet. We've got great companies in the UK making projects like Velocis and Fulcrum and LanzaTech and others, all coming together to make it happen. Flight should not go anywhere. It's important for the globe to stay connected. And it shouldn't be the purview of just the rich. Maybe it's going to be at a premium to start with, but that's where we have to go. And we have to get there. And I'm optimistic that we will.
Thank you. Holly?
I'm also optimistic, right? I think there are technologies, there is appetite, there is progress at a pace that is largely faster than perhaps we expected. But I think that the biggest mistake we could make in the next 10 years is treating this as BAU, right? We've said it, so we'll get there.
Yeah.
So I think really the call to action from Virgin, and I suspect from every panelist up here, would be urgency, right? The next 10 years will define our collective ability to deliver net zero 2050, and we have to move faster.
Thank you. Great. Well, I hope we've left you with the impression that aviation is viable as a decarbonised industry, and that the whole industry is working hard to make that happen. And just like to thank my panelists, and thanks for having us.